What's up, Ethan here. This video is going to be attempting to replace bad LEDs on a LED video wall panel, and I'm going to time it to see how long it will take. There's technically 200 of these modules between the 24 panels, so if I can get a gauge as to what it takes to repair one, that can shed light on what it would take to do all. So, a little bit of background. These panels are scanned 5 pixels wide, so when one of the LEDs goes bad, it causes 4 neighbors to light up. And unfortunately, as it sits on, I've burned this in for about a week to try to force as many as possible. But when I switch it to test scan horizontal, it also triggers a lot more other segments to light up. So I'm gonna try to replace the LEDs and correct that issue. So let me start the timer. Okay, timer has been started. So the first trick that I'm going to do is mark off the LEDs that I think is bad. This is kind of tough because I haven't troubleshot the ones that are scanning. Let's see. So, so these scan in arrays of 5, and the actual modules themselves are 40 pixels by 40 pixels. So 1, 2, 3, 4, 5. We've got a bad one there. 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 So I'm marking these ones. Now the downside is I don't actually know these ones that are strobing when it scans. Huh. I think that one's bad. We'll try that one. That one. Interesting thing on these ones here that are miscolored. Let's see, where's the edge of this module? It's 40 by 40 pixels, which is kind of weird because the I'm used to seeing them in offsets of 8. So I think. Alright, so I think I see what I see. As far as the initial set, we'll kill the power on this. So the story is I found this thing on Facebook. Wow. Just looking at like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, under 2,000 LEDs. This deal came from Facebook Marketplace, and I didn't know that it had been left outside. And unfortunately, the water penetrates the flight cases. Flight cases aren't waterproof. They're large. Water sits on it, gets through the aluminum extrusion on the edges, down in there, and it gets into where the wheel, probably where the wheels, it has cups for wheels for stacking the cases. So, pretty bad shape, unfortunately, because it would have been awesome if it wasn't, didn't have this issue. So next I need to find my screwdriver. I bought a power screwdriver from Harbor Freight, but it's slow and the quality of the bit, I mean, I guess it's Harbor Freight, so the quality of the bit isn't very good, so I actually don't really like it. And I'm trying to find a higher quality one. Because this was left in the, because this thing was left in the rain, there's all these tiny screws. So there's a module that's 40 pixels by 40 pixels, and there's about 210 screws, I think I figured out, in the holding the front plastic on, and this front plastic needs to be removed in order to, so this is probably the largest time consumer, more so than replacing the LEDs, and this is my biggest problem. So I was looking around a little bit trying to find a commercial precision motorized screwdriver. I found there's some higher grade ones that can move at adjustable RPMs. So really that's going to be the only way to tackle this. I literally thought about trying to, you know, build a robot or something out of a 3D printer or something that could unscrew these. But the ones that are rusted, it gets to be a random situation where whether or not it's going to come out or not, and if they don't come out, I have to drill it out. And on the first panel I ever drilled out, 2 of them, I had great success. The second one I tried, I kept cracking the plastic. So now I will have to epoxy that plastic back together. There's 3 rows where, since it's a semi-transparent, I guess, screen, which is super cool looking, it's a P7. But the way it works is the rows where it's got the cuts in it for the transparency, those have a lot more screws. Really, really bad screws I'm setting aside in a garbage thing. The ones that are serviceable but a little bit rusty, I will probably, I'm going to vinegar them and also oil. So coat them all in oil after trying to do some rust removal. Pretty strange. You can't always judge drill that one, drill that. Nope, there's 3 right there that all have to be drilled. Yeah, this is pretty bad row here. So for the time's sake, this is a pretty good one to figure out the There's a lot to drill. Not good. Love it when the heads just break off the screws. Alright, kind of out of the woods there. Most of the screws that are left aren't quite as rusted, but there's a lot of them I have to drill out, which is going to be time consuming. At least this gives me a good reference. All right. Where's our time at? Let's see. 20 minutes to there. So 48 minutes roughly to remove the actual plastic fronts with all the screws that need to be drilled out. Not all of the panels are this bad in terms of condition, but not all of this. I don't know that this is the worst. I can definitely see that there's corrosion on some of the LEDs on the corners, like legs, so I can see that. I wonder if those are the ones with the high rate of failure. I'm cleaning some of the rust out here, I'm afraid. We'll power it up, see where we're at as far as problems, just to make sure it didn't cause any more with the metal in there. Power supply up. Same. Alright, so with it back in our scanning pattern, now comes removal of the surface mount LEDs that are bad. So fun. Alright, so we'll start that. Here in 15 minutes. Issue with the hot air reflow. It's going thermonuclear. Hold up a trace. Time check roughly at 2 hours. That was a total pain. And so even though I did all that work, I pulled up one trace. There's actually 2 traces, but one that I still need to repair. And I'm already seeing like 4 more failures. So, and since that point, more are failing. So I don't have a lot of long-term confidence at all that doing this kind of repair will make these, you know, long-term serviceable. I think they'll still fail. So I don't know that it's worth all the time. Maybe what I might do, I'm not sure, is maybe I'll go through all the panels, sort out the ones that are least problematic, piece by piece within a panel, and then mix and match. But there's gamma issues where some of the panels have a way different gamma than the others. So I don't know if maybe they've been calibrated and then the data stored into them, but these others were not. Missed out on a calibration. I don't know how that piece works with the Novastar stuff, but yeah, so roughly 1 hour, 50 minutes, nothing's reassembled. There's still a lot of metal pieces sticking out of this from where the screws were drilled out that need to be removed carefully without damaging more LEDs. So it's rough. So here you can kind of see where the greens are coming in. Those are failures. I think I missed one of them. So I saw one of them was marked off that I accidentally missed, but yeah, so it's kind of, they call them fangs, I think, from what I saw on Facebook. Overall, not too bad if it's just one, and you can see inside the when you can. I don't know if you can see it in the video, but when it's scanning, there's actually a lot of colors that are out. So. I don't know if I can get in the test mode. It's kind of strange that sometimes test mode doesn't show the, yeah, you can see right here, like, maybe the camera will show the color consistency like crazy. Yeah, so now with it all dark, I've got 1, 2, 3, 4, 5, 6, 7, 8 fangs still, after all that work. Not cool.